Less than 2 years ago, Applied Materials, the largest semiconductor equipment supplier in the world, took a major leap into the photovoltaics industry. Applied's strategy is to leverage its deep knowledge and expertise in the semiconductor and flat panel display industries to become the major contributor to the cost per watt reductions needed for photovoltaics to compete successfully with conventional energy sources. At the Intersolar Trade Fair held in Munich, Photovoltaics International took the opportunity to discuss what strides had been made in the interim period and what we should expect from Applied and its growing customer base in the future, with the head of Applied Materials Solar Business Activities, Charles Gay.
Applied Materials is really about scaling up solar, and with scale comes massive cost reduction. So essentially, this industry is one that's very predictable, one which has a long track record of consistency in performance. And so a lot of what we've been working towards is bringing down the cost of electricity from solar, a part of which is making a low-cost solar module, and by doing that is scale, manufacturing scale, and scale of the product itself. From the manufacturing scale standpoint, much of what we do is to adapt equipment that has already been developed and refined, and in particular equipment from the glass coating industry and equipment that has been developed for making big screen TVs, large area flat panel displays.
One of the key technologies Applied Materials has brought to the market is its turnkey ultra-large thin film substrate turnkey production line dubbed SunFab, which uses 5.7 meter square glass, significantly larger and offering potentially lower cost per watt fabrication than existing technologies being used in the industry. With SunFab orders now in excess of $3 billion, demonstrating its viability in a volume production environment is a key priority for Applied Solar Group after its launch in September 2007.
At the Intersolar show here, we have one of our early customers, not the first one, but one of the more rapid to fleet of foot customers to be able to scale up in 10 months from the time they shovel touched the ground to clear the space for a fab to having a solar panel, and a working solar panel. It's not just for a show, this is for power production. Today they have a pretty exciting event of actually allowing people who've come to the Intersolar show to see how glass flows through a production plant under automated control and produces a panel that they'll actually bring to the show and let everybody see. An amazing accomplishment in a short time.
The speed to market has been a major factor for Signet Solar. 10 months after laying the first foundations at their purpose-built 200,000 square foot production facility, the company has produced the first 5.7 meter square panel. A special ceremony at the plant in Dresden was broadcast live to the show and marked an important milestone for the technology.
For us, we are a young company. We founded in 2006, and by proving out the product for the first time, this is the world's largest module produced first time, we will be able to start shipping to our customers beginning next month. We are sold out for next 3 years, and we'll be adding more capacity, first in Germany and later on in India as well.
The production facility will start production at 20 megawatts of capacity, and by the end of 2009 this is predicted to have increased fivefold. The company's 5-year goal is to achieve 500 megawatts of capacity. Many market researchers and industry analysts are projecting a 20% thin film market share over the next 5 years. However, the recent gigawatt-scale SunFab orders received by Applied could significantly alter this projection.
I think it's actually going to be more. I think that the size of the market for thin films is bigger than most people have anticipated. We're not just extending the past into the future, we're changing the future right now. And we don't have to wait for the future, it's here. We're seeing already a new paradigm, a new set of technologies where The ideas have been incubating in the lab for a long time, in some cases for decades. The ideas have been well refined, they've been tested, they've been checked and rechecked. People know how to make the material. What's happening now is people know how to take the material and replicate that over a large area, over a big piece of glass, and do that over and over again in a consistent way with automation, with a computer that controls how the coatings are done, so that that desired recipe from the scientist who had it in his or her hands in the lab has gone to sort of mass production scale. It's an exciting time where our ability to predict how much is relatively subject to debate, I guess, but the awareness that we're about to change the opportunity in a massive way. Not only do we see it every day, but the general public sees it and understands the connection between what we do with energy and where the energy comes from and the impact on the environment.